Doing a quick video here about gapped cores. I've got a ferrite core in there, two C halves or whatever. They are currently separated by two layers of electrical tape, so there's a gap in between the two of them. We're going to compare it to a gapless setup and see if there's any difference. Alright, here we go. First we're going to take it up to 5 volts. Very fine difference there. 5 volts or so. Using 1 amp at 5 volts. We've got over 50 volts at the cell. We've got 70 volts at the cell. 20 milliamps being consumed right now. Basically no production. We're going to take this up to 10 volts here. 10 volts. We're now consuming 2 amps, so 20 watts. We're up to 100 volts at the cell. 50 milliamps through the cell. Tiny bit of production starting. But we are up to 100 volts. Not a ideal waveform, but there it is. So from 10 volts up to 15 volts, we're now at 3 amps consumed. And we only made it to 110 volts. 80 milliamps running through the cells. Just a little bit more production as expected. We're going to take this up to 20 volts. We're now consuming 4 amps. But we only have 114 volts at the cell. Still 104 milliamps. Production is just a tiny bit better. But our voltage, isn't really much higher than what it was previously. Check this up to 29 volts. As high as we go. This is now consuming 5 amps. And we only made it up to 117 volts. 127 milliamps moving through the cells, but we do have a little bit more production. Again, our waveform is not ideal. It's not equal opposite polarity pulses, but it is unipolar pulses. What I want to try to get at here is that the performance from 10 volts, basically 20 watts, to produce 100 volts to 30 volts, 5 amps, which is 150 watts. From 20 to 150 watts, we're only able to achieve 16 more volts. So, and it's still only 120 milliamps, but do have a bit more production happening. But the point being here is that for a negligible voltage increase, we have a lot more production made, but the threshold between 20 watts to 150 watts input is really negligible voltage across the cell. So there's a threshold here that is optimal for running. So we can push it harder here, but the efficiency goes way down once we reach this threshold. So the idea is to make a transformer run within this threshold so we can get higher voltage with left-hand consumption. Now let's switch it up.
This is Stan's Revenge.
Now I'm going to remove the electrical tape that was on top of these and load it back up. All completed. Alright, here we go. Now we're resonating about 2.5 kilohertz. Waveform there. 5 volts. 0.6 amps. Get about 66 volts across the cell. It's about what we had before. There's 10 volts. Now at 1.5 amps, which I think was just a little bit less. About 100 volts. 50 milliamps across the cell. Taking this to 15. 2.6 amps consumed. Only 110. 80 milliamps. There's 20 volts. 3.8 amps consumed. 113 volts across the cell. 101 milliamps. Expected production. Taking it up to 29 volts, we spike up to 5 amps. 5.1. Only 115 volts across the cell. So not much increase there. Still 120 milliamps consumed. A little bit better production. Theory. A gapped core only affects the frequency at which it resonates at, does not necessarily translate to a higher voltage level. That's my conclusion.
This is Stan's Revenge.